This is our pipe layout. Based on the layout, we have numbering each of the nodes from 1 to 8. The length of each pipe we obtain directly by measuring each node at the AutoCAD. We made assumption water tank height 3 meter, building height 12 meter. To get high supply level for each point, we use all these formula. Proceed with water demand. Based on the guideline, the demand for block is 2 to 5 liter per day, and for the admin or cafeteria is 1,200 liter per day over 100 meter square. For this project, we had divided into 3 loops, which is loop 1, 2 and 3. To find the total demand, we just adding the total demand from each loop. Then we can find for parcel M and N, which is 1.2 Q and 0.8 Q respectively as mentioned in the question. Peak flow. The formula is 2.5 times total water demand. We use the formula for each loop and we find the total of peak flow. Fire flow is equal to fire risk plus total water demand. Since the project is constructed for hostel, admin building and cafeteria, the fire risk fall under class B, which is fire risk equal to 2,700 liter per minute or 3,888,000 liter per day. Since the fire flow is higher than the peak flow, therefore we use the fire flow as designed. Then we use the obtained value for the design reservoir. Q reservoir that we calculate is the same value of volume of total daily demand. Selection of pipe. All diameter of pipe is 200 mm and it is high density polyethylene HDPE because it has high level of permeability and durability, strong molecular bond, high toughness and resistance to chemical, low weight and cost effective. The roughness coefficient of this pipe is 130. Heat balance method. First, we set the circulation of every loop clockwise and then we numbering each node from 1 to 8. Then we propose flow rate as written in the table. The head loss in HBM is calculated by using Hazen-Williams equation. Coefficient roughness is dependent on type of pipe. In this project, we use HDPE, so coefficient of roughness is 130. Then we can find the value of head loss by using this formula. In HBM, also we need to find Q prime for single pipe and joining pipe. Both are using different formula. Those values are very important to do correction in the next iteration if previous iteration total H is not equal to 0. We need to extract all the data and put them into this table. In order to know where to stop, the iteration is where the total H equal to 0. But in this first iteration, we didn't get total H equal to 0. So we need to do correction and proceed with the second iteration. But in the second iteration, also we didn't get total H equal to 0. So the calculation will be repeated until fifth iteration where the value of the head loss is approximately to 0. Whether it is correct. Proceed with reservoir design. From the previous calculation, the volume of total daily demand is 13,3400.93 meter cube and land area is 40 times 90 meters. So this is our proposed reservoir. So the detail of the reservoir is listed, and the most important part is the volume design must be greater than the volume required. So this design are considered pass. Lastly, residual head. So this is the layout where friction loss HF of each pipe has been stated. We have assumed the value of H rise equal to 25 meter, which is the height of the elevated water tank. Then the tank depth D is equal to 10 meter, which is the value of the top water level minus bottom water level. Basically, residual head can be obtained by using this formula: reduced level plus available head minus top water level. We also include how to get the available head H naught. All the calculated residual head in each pipe must be larger than 7.6 meter. Why? Because minimum residual head in design is 7.6 meter. So this design considered passed. In conclusion, our design assumption is correct and we don't have to change the type, the size, the diameter of pipe because it is considered okay since it is achieved all the requirement. So that's all from us. Thank you and stay safe.